Hello guys, so we had discussed many things about the displacement velocity in our previous videos. So let's start with the same what we were doing, and we'll start discussing more and some more topics. But before that, I just want to have a revision with one of our video. Okay, so I'll give you a problem, and let's revise by that. Say if I give you a displacement of a particle, and that displacement is a function of time, and the equation is like this: 5 1 minus cos 2t, okay, I cap, plus 5 sin 2t j cap. So this one is the displacement equation as a function of the time. And what I ask you, find the distance traveled, speed, everything. Find the speed first of all. Find the speed. Find the speed first thing. Okay. And trajectory of the path. You know what path in which it's traveling. You can also find the distance as well. You can do every PhD over it. So let's do. First of all, we know the displacement. Let's solve this question. We know the displacement. We can know the velocity as well. Velocity is nothing but dr by dt, differentiation of that. Okay. So let's differentiate it. And what is the differentiation? It would be 10 sine 2t I cap. Okay. And plus, what is the differentiation of sine is? Cos. So 10 cos 2t j cap. Okay. So this is the velocity as a function of time. Or if I want to know what is the speed, so what will be the speed? Speed is nothing but the magnitude of the velocity. Okay. And what is the magnitude of this velocity? Is 10 square. Can you see that I can take the 10 square common? Sine square 2t plus cos square 2t. 10 I take common and then made a square of that. What is the 10 square plus cos square? It is 1. Basic trigonometry. So the answer is actually 10 square. Root of 10 square is 10. So answer is 10. So speed is 10. Easy question. But let's proceed more and try to find what is the path of this particular particle. So looking at the the equation of the displacement, I can say that the x axis, displacement in the x-axis is like x 5 minus cos 2t I cap, and displacement in the y-axis is like 5 sin 2t. Now I can make a square of both sides. Can you see that? I can make a square of both sides, and if I make a square and then add x square plus y square, it would be 5 square. Okay. Can you see that? What I'm trying to say? Make the square of this one, 5 square, 1 square plus cos square 2t, and minus 2 cos 2t plus 5 square sin square 2t. Okay. So there is a basic equation, and if you are going to solve it, x square plus y square, 5 square cos square, 5 square sin square would make it 1. Okay, so 5 square there. Now I'm just left with 1 minus 2 cos 2t. If you look closely to it, okay, cos 2t, 1 minus cos 2t, what does it makes it? If you know a little bit of trigonometry, cos 2t I can write as cos 2t, cos square. Let's avoid the math, and I'll give you a easy way to solve this. Just let me erase something. Okay, so it was, just a second, was like what was it? 5 1 minus cos 2t. Okay, just some problems with the, and y was 5 sin 2t. So actually I was avoiding mathematics over here, not to give you much mathematics. So I don't know what happened with the intensity of the pen. So tell me one thing, do you understand? I can write from here x minus 5 is equal to negative cos 2t. Okay, so I would just do one thing. I would make a square of this equation and this equation, so that would be making it more easier. So x minus 5 whole square is equal to cos square 2t plus y square plus it would be also 5, so 5 square, there would be also 5 plus 5 square sine square 2t. Now this would make it 1. Sine square cos square is 1. Okay, so ultimately I would have this x minus 5 whole square plus y square is equal to 25. So this is the equation of a circle. That means the particle is moving in the circle and with the center at 5, 0. Okay, so thereby we can also know the trajectory of the particle. So I would say the particle is moving in circle with a trajectory of, with a center of 5, 0. So if I need to draw the particle motion, it would be like this, and the center is, if you know the equation of the circle, I'm thinking you might know 5, 0, and the radius is 5 itself. Okay, 5 itself. So if I want to draw it in the xy axis, so it's like that only. True. Okay then, now let's discuss some more things, and let's get into this new topic. Not the new one, but different one, you can say that. So if I represented x as a function of time, so can I get the velocity as a function of time? Yes, just by differentiating it once. Actually velocity is dx by dt. Okay, this dt is important. Okay, just take care of that. Okay, and we can also know the acceleration. Acceleration would be dv by dt. So if you just differentiate it once, so you get v as a function of time. If you again differentiate it, so you got acceleration as a function of time. You got acceleration as a function of time. Same, we can go in the reverse as well. You have acceleration as a function of time, acceleration as a function of time, and you want to go for the velocity as a function of time. So what would you do? You would integrate it. Okay. And if you want to have, displacement as a function of time, again integrate. So first integration and then again integration. Okay. These are the basic things, but we can play over it, and in fact, so I can make sure, and you can also feel that there could be multiple relation, like x as a function of time, v as a function of time, a as a function of time, okay, v as a function of x, a as a function of x, a as a function of v. So the thing is, there are 6 relation, and we can navigate among these 6 relations. Now I'll want to give you some important function like acceleration. We know dv by dt. This is very useful. We use it a lot. So dv, if I differentiate, if I multiply and divide it by dx, okay, the same thing. dv by dt, I multiply and divide by dx. Now we know dx by dt is velocity itself. So eventually I got acceleration as a function of x, v into dv by dx. Can you see that? So the thing is, dx by dt is velocity itself. It's velocity itself. So ultimately I can write acceleration as a function of x as well. Okay, so this is very important. You should take a note of this. Okay, now I must show you different function, and let's move over it. Okay, let's for your practice. Not a big thing. Say for example, I say you have, I have like x as 3t square. So I ask you v as a function of time, acceleration as a function of time. Then this is a easy one. Velocity is dx by dt. Just differentiate it once, 6t. Acceleration is dv by dt. Just differentiate it once, 6. So acceleration is constant in this case. Can you see that? Okay. Okay, let's do some sets of other problems. Okay, I'll give you one more. Say for example, I gave you this thing, excuse me. Okay, acceleration is like 2t, and I ask you x as a function of t and v as a function of t. Acceleration is 2t. So what I can do, I know acceleration is dv by dt is acceleration. So dv would be a dt. So hereby I can know the velocity as a function of time. So acceleration would be integration of 2t dt. It would be t square by t square. So this would be the velocity. Can you feel that? Okay. And if I need to know x as a function of t, okay, so what would I do? Again, integrate v, dx by dt is velocity. So if I need to x as a function of t, so dx would be v dt. Okay, on integrating this, I would get, just give me the integration of v dt, t cube by 3. Okay. Okay then, thank you.